actually like didn't do school. So.
Didn't do school?
Yeah, like Einstein and those guys. They did not do school, or they only went through a couple grades.
The smartest people created the school system, so they're going to create people who are like, stuck in the matrix.
Well, let's go back on us.
Hey, like I said, always feel free to drop out. Just have a plan in place. So if you're an Einstein, I would encourage you to drop out because you probably have a plan, or you have some like really good, you have things that you're motivated to do and things like that. But most people just want to quit school because they're lazy or they whatever, they don't like it. But they don't have a plan for anything, so it's not really valuable.
It's hard to go to school.
But if you have a good plan in place, and that plan genuinely could be like, hey, I'm really interested in detailing cars. I've got a great apprenticeship going. Looks like in about 6 years I'll take over the business. I'm going to just go full time now because this is my passion. Absolutely. Drop out at 16, work full time, make money, save it, and pursue car detailing, make a pile of money, be wealthy, and enjoy your job. Awesome. I would think that's a great plan. But not many people necessarily know that that's really what they want to end up doing. So it's good to kind of check the boxes. And if you see school, I never disliked high school. No. But that's because I enjoyed hanging out with friends, playing basketball at lunch every day, the sports teams. I just enjoyed the people. And I mean, the teachers were like marginal. Some were great, some were awful. The standard. So I never disliked it.
Even like the last week of high school?
No,
Really?
we never got
Really
it.
excited.
We just enjoyed it.
Yeah.
Now, I can't speak for everybody, but yeah, even the last week, it was like, I don't know, we just were having a good time. And I was like involved in tennis, so we were going to like the tournaments and divisionals and state, so I had stuff going. So, but that's okay. I mean, everybody's different, But I didn't necessarily like love school, like academics. It wasn't like I was like, oh, I just love learning. I just enjoyed the people. And the learning wasn't, and I wasn't like that smart, but learning wasn't like brutal. It wasn't like, but I don't think your education stuff here is brutal right now. Maybe advanced math is tough, but I wouldn't call it brutal. AP test is tough, yeah. And I remember those stressors, taking the AP exam. My mother was the teacher, and that created a stressor. I didn't.
You didn't?
I got a 3, which is passing, but Wheaton, where I went, they didn't give me any credit for it.
So I got on the AP Bibles.
So it's passing, but it depends on where you go to school. So I was on 2 out of the 19 kids. I was one of the 2 that got a 3. Everybody else got 4 or 5.
You know, Emmy got a 5.
On the
I
bio?
got a 5.
Emmy?
Yeah.
Serious?
Yeah.
I need to remember all that.
Yeah, Mr. Norbert was like, well, if you need help, let's turn up with something. I was like,
Wow, that's awesome.
Yeah, how'd your Gabriel got like a 6 or something?
The impossible 6, yeah. Absolutely. Okay, this is 20.4 going on. So 20.4 talks about velocity and acceleration. Velocity, if you talk about velocity, anybody know the other name for velocity? Speed. So speed is another word for velocity, but speed would be like in your car, you have a speedometer, right? And the thing is, velocity can be negative, but speed is always positive. So when you think of velocity, just try to think of it as like speed. You're going 60 miles per hour, 20 feet per second or something like that. That's what velocity is. Okay, when we talk about velocity and acceleration, we first have to start with what we call the position of an object, or in this case, they show a car. Okay, so a position function. Now, position they describe with the letter S. They actually don't describe it with D for like distance. actually describe it with the letter S. I think it comes from a Latin word. I could be wrong there. But you probably won't take the time to look it up. So let's just say it comes from the Latin word S. Kind of like slope, M, right? The letter M stands for slope. S does not stand for slope. It stands for position of an object. Okay, so in this, we can have negative, we're going to say positions in the sense of this. If this is your starting point, so like if I have a starting point here, and actually I've been to some museums that have this, you know, like the science museum or something, they have a machine that reads your speed as you walk towards the machine. So if this is my starting point and I walk this direction, this is in a positive direction because I'm going, and if you think of it like an X, Y axis or an X axis. And then as I go back, I'm still in the positives, but once I reach my starting point and I go backwards, now I'm in the negatives, okay? So you can have a negative position based off of where you are in relationship to your starting point. So as you look like a graph like this, it's coming down. Well, can the distance really be negative? Sure, if you're going past your starting point. Okay, so you can have a negative distance. So S stands for our position function. And then this is a graph that represents the distance of, let's say, this vehicle driving over an amount of time. Okay, so let's say you go 60 miles in 1 hour. Could you find your speed or your velocity, your rate, 60 miles per hour? If you went 100 miles in 2 hours, could you find your speed? What would you do to find your speed or your velocity? 100 divided by 2. If you went 100 miles in 2 hours, right? So you would say 100 miles in 2 hours is 50 miles per hour. So if you wanted to find your average velocity, because if I said, hey, I went 100 miles in 2 hours, you don't actually know how fast I went the entire time. Maybe I went 75, then I dropped it down to 40, then I increased it to 55, and blah, 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 back and forth. The only thing you know is that on average, I went 50 miles per hour. It took me 2 hours to go 100 miles. So if you want to find your average velocity, okay, the average velocity, that would be found by simply taking your distance traveled divided by your time. Now the book describes it as delta S over delta T, and again the delta S is referring to S sub 1 minus S sub 2 over T sub 1 minus T sub 2. S is your position, or you can think of it as your distance traveled. So that's fine to think of it as distance traveled. They just use the letter S. So if I wanted to find what is my average velocity for, well, you can use the points given. If I want to find my average velocity between those 2 points, I'm just going to find the what between the points. What am I essentially finding? I mean, it's called the average velocity, the slope between the 2 points. So what's my average velocity between these 2 points? Well, you figure out this point is, what's its coordinates? 1, 1, and what's the coordinates of this one? 3, 6 about, okay? I think so, that looks good. So what's the average velocity over that course of time? Five over 2, so in this case it's 2.5, not miles per hour, but meters per second, right? So 2.5 meters per second. 2.5 meters per second. So that's our average velocity. Now, you can maybe see where we're going with this is I'm finding, okay, the slope between these 2 points right here, that gives me my average velocity. A line connecting 2 points is called a, what do we call that? Starts with the S. Secant, right? It is a segment too, but we refer it to a secant. But if we want to find out what is the velocity at any given point, right, then you're going to need to find the derivative. Yes, the derivative. The slope along a curve, not just the slope, but the slope along a curve. Okay, so then, that kind of discusses this idea of average velocity. And we could say, okay, we want to find the average velocity. Now, when we do this, then we can look here, if we were to transition to this next figure here, if we were to look at this velocity here was positive, right? 2.5 meters per second. The velocity we find here, what's the velocity of that going to be, positive or negative? We don't have numbers for it, but what's the velocity going to be, positive or negative? Negative, right? So it's going to be a negative velocity. What that's referring to is, like I said, you would be moving forward from your starting point, so you're positive, positive, positive. At some point I stop, put myself in the camera lens here. At some point I stop, when I stop, what's my velocity? 0, and then I go backwards, what's my velocity? Negative. So if you look at this, here you have a positive velocity, positive velocity, positive velocity, and then what happens? A velocity of 0, and then all the way down. Now we know it's a velocity of 0 because if we wanted to find it right there, the tangent line would be a slope of 0, so therefore your slope or your velocity would be 0. So this would be negative velocities continuing down, negative velocities below the x-axis. But again, what this is representing, the negative distance as it continues on, is I got back to my starting point and I kept going past the starting point, so in a negative direction for that. Now, if you wanted to find, like, what is the velocity at any given point, like 1, 1 right there, what you would need to do is take your other point that we had, and what would I do with my other point? If I want to find out what is the slope right there, I need to take this other point, move it down, and move it how close? Infinitely close, and you would find the, you already mentioned it earlier, derivative, and you find the derivative by finding the limit as h approaches 0, meaning the distance between this and this we call h, as that goes to 0. So then, once we find the slope, remember the slope between 2 points on a distance and a time, that gives you your average velocity. The slope between 2 points, like if the 2 points are like that, would be the average velocity still. But as those 2 points become infinitely close, yes, technically it's 2 points, but essentially you're looking at what is the slope at that 1 point. Here, they've just given you a general, they found it for you or gave it to you. They say, hey, that slope is 3/4 there. But there's no function for us to take the derivative of and actually find that. So that number 3/4 is just given to you. You're not needing to, how did they find 3/4? They just made it up or whatever. But it looks approximately to be 3/4 there. The same way we know the slope here is 0, we can just look at it and say that's 0. Now, the slope here, they're just referring to having 2 points that you would move infinitely close to each other. Yes. Okay, so average velocity, just finding the slope between 2 points. Velocity, or v of t, is equal to instantaneous v of t equals instantaneous velocity. So average velocity, you just find the slope between 2 points. The instantaneous velocity is going to be found by doing the limit process. We'll write this up there. And we'll look at it in a capacity with the letters that they use. And I'm going to show this because it's actually good to see something a little bit different, and I'll explain it to us. They don't use the limit as h approaches 0. They use the limit of as delta t goes to 0. Okay, so delta t, and then which is the change in time, And then this is s of t plus delta t minus s of t all over delta t. Now it adds these extra variables and symbols and makes it look a little more complicated, but it's the exact same thing as what we've been doing with the limit process. So there's nothing new about it. All they're doing is stating that you have a, if we take a look at it here, this upper graph here, this right here is an s of t function. So it's a position function, distance s, t, time in seconds. So what it's stating is that you would go over, if you wanted to figure out your y value, you plug in t right here and output s of t. And so that's where the s of t function idea comes from. And so y2 minus y1, if you will, we can, they have it kind of here, I guess, but we could state, okay, if this is right here, the point we're looking at, that's over t, some amount, up s of t. Like that. We just don't know what s of t is. Usually we have like f of x equals x squared. We just don't know what s of t is in this case. It's just a general function. So then if you wanted to find out what this point is right there, you would go over t, and we were using, if you remember, you would go over t and then plus some h amount to go over. So we were saying t plus h, but all they're stating is instead of t plus h, it's going to be delta t, some change in amount of time. So instead of t plus h, it's delta t, like that. Well, it's t plus delta t, I'm sorry, instead of t plus h, it's t plus delta t. So you go over t and then a change in t, which is the same thing as h. So think of h and delta t as the exact same thing. And then to get out your y value, you just plug that into your function, and it would be t plus delta t, like that. So that's your other y value. So there's your two y values, and you plug in here and then do the limit, and that gives you the derivative. So the velocity is, the instantaneous velocity is equal to the limit as delta t goes to 0. Now, what we're actually doing then, like you've stated a little bit, this is the derivative. Another way to write the derivative for notation is just to say s prime of t. So s is your position function, and so the derivative of the position function, this is important to remember, the derivative of the position function is going to be your instantaneous velocity. Average velocity, you don't need any type of calculus for. Instantaneous velocity, you need to take the derivative of the position function, and that'll give you what your instantaneous velocity is. Because the position function is going to be a curve, and then to find the derivative of that, that will give you the slope of anything along the curve. So this will get you started. At least you can look at some stuff if you want. 20-3, let's say that's due on Tuesday. Due Tuesday. Yeah, this is 24, but 20-3 will be due Tuesday. And I'll get the last couple tests to you guys, whatever they are, 17.